Okay, dear students, in last lecture we have studied fourth application of derivatives, that is approximation. Now in this lecture we will study the fifth application of derivatives, that is increasing and decreasing functions. So how we will check whether the function is increasing or decreasing by using this derivative. So first we will understand about increasing function. So increasing function in short means what? So as x increases, its dependent variable y also increases, and as x decreases, y also decreases, then that function is increasing function. So here if we plot the graph, x-axis and y-axis, suppose this origin. So for increasing function, as x increases, y increases, then increasing function. So we get the graph like this. So for this graph, as we are increasing x, y also goes on increasing. So this function f of x. Now we will consider, suppose interval x is equal to a and x is equal to b. So we will check whether in this interval AB the function is increasing or that. So for that, we will consider two neighborhood values in this interval. So x1 and x2. So that x2 is greater than x1. Now corresponding values of y. So here y is the function f of x, that is f of x1 value, and this value is f of x2 value. So f of x is increasing function in open interval AB if for x2 greater than x1, f of x2 greater than f of x1. So if this condition is satisfied, the function is increasing function. Now here, as this application is of the application of derivative, so how will you use the derivative for this increasing or decreasing function? So for that, we study the tangent. Now if we draw the tangent at any point P to this curve in the interval AB, anywhere if we draw the tangent, now this tangent makes inclination of this tangent psi, that is the acute angle. And you know this slope of the tangent is equal to tan psi. So tan psi, so since tangent, for increasing function, another condition we get, or for increasing function tangent to curve makes acute angle with positive x-axis. Therefore, now slope of the tangent is positive, means tan psi, that is nothing but equal to f dash x greater than 0. So thus for increasing function, f dash x is greater than 0. So if the f dash x is greater than 0, the function is increasing function. So this concept we are using to solve the examples to check whether the function is increasing function or decreasing function in derivative. Now comparatively, we understood about decreasing function. So decreasing function means what? In short, as x decreases, y increases. Opposite will get, and as x increases, y decreases. So here, if we plot the graph of this decreasing function, so that graph will be coming like this. So here, y is equal to f of x is the function. Now we consider the interval x is equal to a and x is equal to b, suppose. Now we consider 2 points, neighboring points, x1 and x2, functional values, y values, f of x1, f of x2. Now here, f of x is decreasing function in interval AB, open interval AB, if for x2 greater than x1, f of x2 less than f of x1. So here f of x2 value is less than f of x1, but x2 is greater than x1. Or now if we draw the tangent to this curve at any point in interval AB, so tangent is coming like this. So obtuse angle is made by the tangent, that is inclination is obtuse. So for increasing function, for decreasing, for decreasing function, tangent to curve makes obtuse angle with positive x-axis. Therefore, tan psi is equal to f dash x. Now obtuse angle is there, so tan value is negative, less than 0. Thus, for decreasing function, f dash x is less than 0. So this you want to keep in the mind, and we'll solve the examples for increasing it. So in short, you keep in the mind, for increasing function f dash x is greater than 0, and for decreasing function f dash x is less than 0. Now by using this concept, we'll solve some examples. So test whether the function f of x equal to x cube minus 6x12 plus 12x minus 16 for x belongs to R is increasing or decreasing. Increasing or decreasing. So solution. So function f of x is equal to x cube minus 6x square plus 12x minus 16. X belongs to R. Now here we will find f dash x. So differentiate with respect to x. So f dash x equal to 3x square minus 12x plus 12. So now this is equal to, we can write 3 common, will take outside, x square minus 4x plus 4. So this is nothing but equal to 3. Now this is the complete square, x minus 2 bracket square. Now here x minus 2 bracket square, what may be the value x minus 2, what may be the value of x. As we are doing the square, always the value is positive and 3 is the constant. So therefore f dash x is greater than 0 for all x belongs to R. And therefore, so as f dash x is always positive, therefore f of x is increasing function for all x belongs to R. So always function f of x is increasing function. Second example, suppose we will see f of x is equal to, suppose, cos x 0 less than x less than 5. Now we will check whether this function is increasing or decreasing function. So solution, f of x is given cos x in 0 less than x less than 5. So f dash x is equal to minus sin x minus sin x. Now you know this, since sin x is always greater than 0, positive value, in 0 less than x less than 5, that is first and second quadrant. So in trigonometric function we have studied this, how we will take the signs AS, TC. So in first quadrant all positive and second quadrant sign positive, meaning of that sign is always positive in first and second quadrant, that is in interval 0 to 5. So this value is positive and this here minus sign. Therefore f dash x is less than 0 for all x belongs to 0, 5. Therefore f of x is decreasing function in interval 0, 5. Third example we check, take this. Find the value of x. Find the value of x such that f of x equal to x raised to 4 minus 2x cubed plus 1 is a decreasing function. Decreasing function. So solution. So f of x is equal to f given x raised to 4 minus 2x cubed plus 1. So f dash x is equal to, take derivative, so 4x cubed minus 6x square. Derivative of 1 is 0. So f dash x 4x cubed minus 6x square. Now since f of x is decreasing, function, therefore f dash x is less than 0. Therefore 4x cubed minus 6x square must be less than 0. Now common will take outside, so 2x square common outside into bracket 2x minus 3 less than 0. Now here this 2 is a constant, that is always positive. X square, what may be the value of x square, is always positive. So this term is always positive. And you know this product must be negative. So this value must be negative. And you know this plus minus minus. So therefore this 2x minus 3 must be less than 0. So x must be less than 3 by 2. So x value take. So that is infinity minus infinity less than x less than 3 by 2. So in this interval we can take any value so that the function is decreasing function. So in this way you solve the examples for this increasing decreasing functions.